In this next example, we look at a man who's throwing a ball straight up into the air. Now we said that when a guy's throwing a ball straight up in the air, it's still undergoing free fall. Okay, so here's our man standing on the ground, and he throws the ball straight up into the air. And as soon as the ball leaves the man's hand, we say that the velocity of the ball is 30 meters per second. So our initial velocity, or v naught y, is equal to 30 meters per second. We know that when we throw a ball straight up into the air, it's going to slowly start to decrease until it hits its maximum height, and it's going to hit 0 meters per second and start to fall again. And so no different here. The guy throws the ball straight up in the air, and our Vy will be 0 meters per second. Okay, so we see that the velocity is going from a higher value to a lower value. So we have called that deceleration. This object is undergoing deceleration. And if we plot this guy at t equals 0, this is what v naught y means. The velocity at t equals 0 is 30 meters per second. And we'll see that the plot kind of looks like this. Again, it's a straight line, which we would expect constant acceleration problems to produce on the v versus t graph. And so let's look at this. So as 1 second passes, we see that our velocity has dropped almost 10 meters per second. If we go draw this line over, it's about right there. And it actually changed by it decreased by 9.8 meters per second in that 1 second. So again, let's look at our acceleration equation. It's the change in velocity over the change in time. In this case, our change in time was 1 second. And our change in velocity, we're saying, is negative 9.8 meters per second. Okay? And this equals negative 9.8 meters per second squared. And this is acceleration in the y direction. And it turns out that we see with the negative sign that acceleration is pointing downwards. We saw in our previous problem when the ball fell from the roof that it was accelerating at a rate of negative 9.8 meters per second squared. And now we're saying this ball is decelerating at the exact same rate. And it turns out that, again, all objects that are thrown into the air are going to decelerate at this exact same value. So for every 1 second that passes, the objects are going to decrease in velocity by negative 9.8 meters per second. And so if we go from 1 second to 2 seconds, we see that the velocity again has decreased by, 9.8 meters per second. And so we're down to close to about 10 meters per second. And then it takes about a little over 3 seconds before the velocity hits 0. And that's when it hits its peak. Now, it's important to notice that even though the velocity is 0 here, the object still has acceleration. Don't confuse velocity and acceleration. The Earth is still pulling this ball down at its peak towards the Earth at negative 9.8 meters per second squared. It just happens to have 0 velocity at that time. And that's what we mean by free-falling objects. And to summarize, these objects are rising and falling, and their velocity is changing at a rate of 9.8 meters per second squared, meaning that every second that passes, their velocity is going to change by 9.8 meters per second.